Now let's solve the following limit. Note that our function in this case is x cubed minus 1 over the square root of x minus 1. The first thing that we need to make sure that we get is that the domain of definition. Here, the square root is defined when x is greater or equal than 0. And also, we don't want to divide by 0. Therefore, we have the square root of x minus 1 must be different from 0. That means x must be different from 1. Okay? And we will see that in this case here, that we can make or change this function. Okay, and we're gonna talk about this discontinuity at this point 1. Okay, now let's find this limit. Assume that we can find some value. So if we plug x equals 1, we're gonna get 1 cubed minus 1, which is 0, over the square root of 1, which is 1 minus 1. So we get 0 over 0. This means that we can do some effort to find the limit. Okay, one quick way is that we have x cubed minus 1 over the square root of x minus 1. So if we apply the conjugate, we can multiply top and bottom by the square root of x plus 1. Okay, once we do that, we see that we have x cubed minus 1 times the square root of x plus 1 over x minus 1. Okay, and we're gonna use some factoring of x cubed. So x cubed minus 1 is x minus 1 times x squared plus x plus 1. Okay, so when we plug this one here, we're gonna have x squared plus x plus 1 times the square root of x plus 1 and over. So we're gonna have x minus 1 over x minus 1. Okay, so now x is different from 1, okay, because the function is not defined at 1. Okay, therefore this is always different from 0, so we can cancel by it. Okay, therefore this limit of x cubed minus 1 over the square root of x minus 1 as x goes to 1 is gonna be this limit here. So it's gonna be the limit of x squared plus x plus 1 times the square root of x plus 1, and we know how to evaluate these ones. Okay, we can just plug in because this is a rational, okay, and this is a polynomial. We can just plug in the value and see if we have a finite one. So here, when we do that, we're gonna have 1 plus 1 plus 1, 3 times square root of 1 plus 1, which is 2. This gives us 6. Okay, so here we can see that we have this discontinuity as 1. We can remove it because we have a limit here. Okay, so there is a limit that we reach when we get to 1. Okay, so we can say that we can remove this discontinuity as this point 1 by redefining this function as, so f of x is gonna be x cubed minus 1 over the square root of x minus 1 when x is not 1, but it's 6 if x is 1. Okay, so we don't have problem anymore on 1. Okay, and if we graph the function now, we're gonna see that we don't have this discontinuity at this point. Okay, so we find this limit, and this kind of discontinuity we can remove it. So that means that that point where the function is not defined or doesn't have a limit, we can fill that point. Okay, so if we have a function like this, but with this point here, so we can find a value for that value, that value where x is not defined or the function is not defined. Like in our case here, so x is 1. Okay, so but if we give to x the value 6, okay, so we see that we're gonna remove this discontinuity. So in this case, we get rid of this one here. So this function is defined everywhere. Okay, so with the issue was on 1. So in 1 we filled the gap. So in 1 we had this new value for the 1. So when x is 1, we have the value 6. and therefore we don't have problem at 1 anymore. Okay, so we call this one a removable discontinuity, and this is one of the examples of that.